Okay. Yesterday we saw Rolle's theorem, right?
Yes.
What's going on with Rolle's theorem? What has to be true? Huh.
There's 3 rules.
What has to be true? 3 hypotheses. 1, F has to be continuous. Where do I look for discontinuities?
The domain.
The domain, exactly. Domain problems. And domain problems could happen, quick review, a pre-cal where? Denominator can't be 0. Logarithmic argument can't be, well, must be greater than 0. Even powered roots, because odd powered roots, any problem?
No.
Nah. Even powered roots. Argument has to be greater than, or equal to 0, right? What's square root of 0? 0. 0 square root of 0, that's legal, right? Somehow our brains are always like, 0. Anyway, anything else? Trig. Trig. Like, for instance, tangent of, when is tangent undefined? Pi over 2, negative pi over 2. Where is cotangent undefined?
0 and
0 pi plus pi n. Where is, sorry, pi over 2, negative pi over 2 plus pi n for tangent. Where is secant undefined? No, he's fine at 0 and pi.
Then
Pi over 2 plus pi n. Why? Because secant is the reciprocal of cosine, and cosine can't be 0 then, and he's 0 at over 2. That's nice. Cosecant, where is he undefined? If not pi over 2 plus pi n, he must be the
Other one.
0 plus pi n. Okay, or pi n. Come back. All right, fine. F has to be continuous. What else? F has to be? What does that mean?
Able to be derived.
Able to be derived. Hold on, listen up close. Continuous, the original function is continuous, right? Domain problems, look at them. Differentiable, the derivative is continuous. Wait, what? Right? Differentiable, the derivative has to be continuous, aka the derivative can not exist. Okay, so check out the domain of the derivative, and then f of a has to equal f of b. Did I say this yesterday? I don't think I did. In order for Rolle's theorem to be true, you have to, from a to b, if you were just going on a secant line cutting straight through the graph, you'd have to roll flat. I don't know, it's a way of remembering. Rolling, okay? So if you're doing Rolle's theorem, you're rolling flat from A to B. If you were just to do the shortest distance between 2 points, you would roll flat. There wouldn't be a slope. Or there would be a slope, and it would equal 0. Now, what's different with today? Guys in the back, peanut gallery? Oh, roll flat? Because f of a has to equal f of b, aka if I was just to cut through and not do all the whatever the path was. Remember our ones yesterday? If I was just to cut through from A to B, if I was just to cut through from A to B, if I was just to cut through from A to B, I'm rolling flat, aka rolling is like speed, right? Like you're actually moving. Nick, Rolls is the guy's name. I'm just making up something. If you don't like it, just ignore it. Sound good? Good. Okay, so keep going. Mean value theorem. We can tilt the picture. What? There's a picture? Someone has their phone on, it has a whistle. Shh. I already got on period 1 for an imaginary phone making noise. Tell them sorry if they talk about it. It was a useful. Anyway. They didn't say anything though. That was really weird. They just kept on looking at me getting mad about the phone. No help. Mean value theorem. We can tilt the picture of Rolle's theorem. We can.
Where?
It's an iPod.
What?
No, she's not doing anything bad. Her notes aren't out. She's like not doing it.
Oh.
I'm paying attention.
Okay.
That's what I do.
Get out a piece of paper, a blank one, so you can do examples with us. Does that sound good? No, not for me.
I don't have any other.
Anybody have paper?
Yeah. Why not from here?
Steal from the rich to give to the poor.
Okay.
Hold on her.
Or paper. Yeah, she doesn't have much of that paper currency. Actually,
Steal
there's
from the
some.
board and just keep it. Nick.
I don't even know what he said, but I'm ignoring it. Shush. Haley, ignore it too. Whatever he said.
I didn't even.
Good. We both. We can tilt the picture of Rolle's theorem. What picture of Rolle's theorem? This picture of Rolle's theorem. Rolle's theorem says, hey, you have a function. He's continuous, he's differentiable. I'm going from an A to a B, right?
Right.
But what's not in the conditions for mean value theorem, aka affectionately known as MVT? Yeah, f of A does not have to equal f of B for MVT to be applicable. Rolle's was the specific f of A has to equal f of B. MVT says, I don't care, as long as he's continuous and differentiable, I can tell something about his derivative. Doesn't just have to, you don't only know something about the derivative of functions whose y values over a close interval are equal. Oh, I just realized my phone is on sleep, so they're probably not hearing anything I'm saying. Hello. Okay. My microphone was off. So, guys, if I was to try to make a picture of this, now once again, I just have to pick one. It's going to be an example. It's not going to be comprehensive, right? But I'm going to have an f of A that's something different than the f of B. The heights are going to be different. Now think about all the different ways I can connect these two with no sharp points, no vertical tangents, so it's going to have to be somewhat curvy. Well, does it have to be curvy? No. How could I connect it?
Straight line.
I could do a straight line, right? That's what the AP is going to assume that you think it has to be a curve, and they're going to be like, must there be a zero derivative, a horizontal tangent line? No, there must not be, because it could be a line, right? But there could be a curve, right? Or there could be lots of curves. Who knows? But however you connect it with a continuous and differentiable function f, what is going to be true? Not that it has a zero, but that it has a slope of the secant line, whatever that might be. Now, guys, for rolling flat, what was the slope of the secant line if f of A equals f of B? Zero. And what must there be at least one place where the derivative equals? Zero. So what does MVT say? Well, that works for anything. For any two heights of any continuous differentiable function, I can say whatever the slope of the secant line is, whatever the slope that goes through is from A to B, there has to be at least one place, if not more, where the slope of the function will be the same. Another way of thinking about it is the slope of the tangent. Remember, f prime, the slope of the tangent is going to have to equal the slope of the secant line between A to B. You have to have an A and a B, or else you cannot have a slope between the 2 points. That's algebra, right? And then down here, another way of thinking about it is that the actual has to equal the average at, guys, when it says C, is it saying it must only be one? No. What's a better way maybe of saying this? At least. Remember, it could be more than one, at least one. This is why you were so confused. This is forever number. My visual ones, you might want to put the picture as well. It can help. This is your forever number 25. This is the last forever of chapter 5. And chapter 5A, thank you. Chapter 5A. And, because remember, like we went randomly from 1 to 2, well, that's kind of normal, to 4 to 7.
We're gonna do that one.
We are going to do the other ones, but not in chapter 5A, not before chapter 5A, which is soon after break. Do we have it?
Yeah.
What's that? 3, 2, 1, go. 3, 2, 1, go. 3, 2, 1, go.
Okay. Now, let's start graphically. Let's start graphically because we can visualize it, we can see it. I'm opening the door because it's kind of warm. Let's start graphically. I didn't even give you a function, but I gave you a graph. Question. First of all, does it meet the conditions of MVT?
Yeah.
From what we can tell, looks continuous, no holes, no vertical asymptotes, no breaks. Okay, continuous and differentiable. Oh, they say it's that. All right, cool. Then there must exist, according to my theorem, it's continuous, it's differentiable, there must exist at least one of these in between the open interval a to b such that. Guys, how many times in this graph, just graphically looking at it,
4.
how many c's will there be? Remember I said at least one, but how many will there be on this one? 4? Where's one? Where's one of them? Right where?
Right.
There's one. Ish, right? Where's another one?
There.
There.
Where's another one?
Up there.
No.
Where's another one?
Up there. There. Yeah.
So I have 1, 2, 3, 4 different c's, right? What's the main one I'm using? Remember, slope of the secant line. I'm just connecting f of a and f of b. I'm ignoring the curve. That's a horrible line. Just pretend it's good. I'm looking at the slope, right? How would I find this slope? I have a point and I have a point. I would use my f of b minus f of a all over b minus a, right? I would use my average y2 minus y1 over x2 minus x1 formula. But guys, how am I going to find the slopes of this one and this one and this one and this one if it's only including one point that I can find on my function? Well, slope at one point, what do I find? Slope at one point. Take the derivative, right? The derivative of, well, I don't know, I guess he could be like C1 and he could be like C2 and he could be like C3 and he could be like C4. Anyway, long story short, I would take f prime of all my c's and these two should be equal. This was really general. Had a specific graph, we started seeing, oh yeah, that kind of makes sense. They all would be parallel to, right? So, estimate for me on the interval 0 to 7 of this graph where the c's, just estimate, I know you don't, some of you don't like estimating, but do the best you can. Estimate graphically my c values. Estimate graphically which x's would satisfy the mean value theorem. It can be approximate. We got some randomish decimals in period 1. See how close you get. I'll give you a hint. There should be 3 of them. Estimate as best you can at what x's, aka what special x's that the theorem calls c's, would this function satisfy the mean value theorem MVT on interval 0 to 7. Speaking of mean for a second, we're looking at the slope between the endpoints, slope of the secant line. Instantaneous rate is the derivative. What's the secant line, guys? Average rate. Wait, what's mean stand for in math? Average. Oh. It's not called mean because it's a mean theorem. It's called mean because it's talking about the average value of the slope and saying, hey, the instantaneous slope is going to equal the average slope somewhere, at least once. Kiddos, is he continuous?
Yeah.
Do you think about it? He's continuous. Is he differentiable?
Yeah.
Did you think about it?
Kind of. No.
Kind of, no, not really. Okay, he's continuous. He's differentiable. What am I visualizing? What am I visualizing in order to find my c's? The slope between the endpoints?
Yeah.
So the endpoints are going to be at 0, 0, right? That, well, is it 0, 1? I don't know. Do you guys think 0, 1? Okay, I'll do that. 2, 7 something. So then, if I'm trying to think of what other places, what'd you guys get as your hypotheses? X equals or C equals? That's a special X name. What'd you guys think? 1.45? We'll say 1.5.
I don't know.
What else? 4.8? What else? 7.8? Let's see how close you were. Ish. I'm approximating 2. Looks to be about
1.2.
1.2 maybe. Might have been a better one. If we were to actually like graph it and see. Maybe like 5.1-ish would be a little bit closer. Not that I'm saying your guesses are bad, your guesses were actually pretty good. I was just saying if we were to be as precise as possible.
Oh.
7.4 maybe.
Do I
That's over 7.
make that a valid point?
What?
Good question.
Go ahead, Ben.
How are you using 7.4 if the interval only goes from 0 to 7?
Ooh, good question. So, what was true about the 7.4 and the 7.8? They were over, which means, do they satisfy the mean value theorem?
No.
It's the mean value theorem. Now you might say like, well, but it has the same slope. All right, I totally agree with you. I totally agree with you. It does have the same slope, and there might be a place for that. But if they're looking for the values in between 0 and 7, we should cross him out totally. We'll go back to our 5.1-ish and our 1.2-ish. Was that what we said? Anyway. Pretty good. Does that make sense? Okay, let's go algebra. Algebraically. Why did I do so many like visual things? Because I'm hoping then when you see mean value theorem or MVT in a question you can say, oh that's right, the tilted one. Okay, the average slope equals the instantaneous. Algebra, how would we translate that then? Well, hold on, we can't translate anything until we do what?
This one
Is it?
Yes.
Continuous? Good, it's a polynomial, I'll take that. Or its domain is all real numbers. Is it differentiable?
Yes.
Why? What's a polynomial? Wait, differentiable is a polynomial? What's f prime of x? We're going to need it anyway in a second.
3x.
Ah! He's a polynomial, so therefore he's continuous, therefore the derivative exists. You guys had good rationale, I just was playing with you. So, I can't say Rolle's theorem. But that's okay, because technically mean value theorem is the more general one. It works for any relationship between f of a and f of b. And if it happens to be f of a equals f of b, well, when I find this f of b minus f of a, I'm going to have 0, so it's going to work. Anyway, come back. We give Rolle's his due credit because he did it first. He found it first. But so MVT applies. Wait a minute. So specifically for this example, what does the derivative of f have to equal at some or for at least one value c? Which is going to be? Sorry, I was looking for notation. Thank you, my ones who are trying to solve for me, though. I appreciate it. 4. Some, and technically you could say maybe some sounds like plural, that might be bad, for at least one. Why do I write stuff? So that hopefully you get used to all the rationale behind what we're doing, why it works. So how do I actually find C? Plug it in. I plug in f prime. I plug in f of 2 to the original, right? The original, don't get confused, label it well. Or else there will come a point that you're like, wait, where am I plugging it in again? Plugging it in, I get 8 plus 2 is 10, 10 minus 4 is 6, good, minus negative 6, good, all over 2 plus 1. Therefore, I get 12 over 3 is 4. Now I need to solve. How do I do that? Well, 3x squared equals 3, x squared equals 1, x equals plus or minus 1, x, well, he's my special c. You can call him x or c, either way. It's the special x value. Question, should I box both? Pause, don't look at me for affirmation. Go read your mean value theorem again and tell me definitively confidently, which ones I should box.
So,
Read your mean value theorem. Read your conclusion. We already got the if continuous, if differentiable.
what is it? STC. Like S dot T, like,
Oh, such that.
huh?
Both or one?
No.
One. Which one?
Positive one.
X equals positive 1. Why? Because MVT says for some C within open interval, -1 to 2. -1 is technically not included in that. They were just looking for positive 1. If you were being technical. Huh?
Wait, so they look at positive?
Well, -1 is an endpoint, and so technically you're right. Both of these x's is where the derivative equals 4. But if I'm looking for the c's that satisfy the mean value theorem, I can only choose, I passed it. I can only choose the c's in the open interval. I don't choose endpoints. It's kind of like if you have a question, they say, find all the ones on. Okay, 2 more. We're doing pretty good. Dos más. Read the directions carefully. We may discuss it if you would like. We'll give you just a few minutes. You guys see what honors pre-cal is starting in on right now?
No. Oh, shoot.
T-proofs. So fun. How many of you guys actually like T-proofs? Why are we all groaning? I love T-proofs.
T-proofs or
Oh,
No one liked T-proofs? This is
no?
my
Daniel
hand.
likes T-proofs.
Nobody remembers T-proofs.
I see one hand,
What's
but
a
it's
T-proof?
hidden. I see 2 hands. Really? That's it?
What's a T?
What's the T-proof, guys? Come on.
And they prove it, right?
Well, you guys see it right here. Verify that this equals 2 cosecant. They're doing like section 5.1. It's the easy, well actually it's the hard one where they say like factor to some magical answer you don't know. But T-proof, remember? And then you start with one side and you go.
Magic.
Yeah.
Oh, that was pretty good.
That was fun.
2.5.
2.5.
3.5.
I'm gonna be like a half.
There we go. No, I kind of Matthew as a whole, but I kind of had Josh as a half because he said kind of.
Yeah, that's good.
Well, no, you didn't say fun. You said it's not. It wasn't that bad.
It wasn't that bad.
Thanks, Josh.
It's still a half.
Vectors?
Vectors, yeah. Vectors are gross.
All right. Are we done?
Huh?
Who's done with A? Let me see hands. You should all be done with A. Why?
It's not continuous.
Easy.
Condition 1. Does he pass?
No.
No. Why not?
Because he's not continuous.
Be specific. He has a vertical asymptote at. Wait.
One.
How did I know it was a vertical asymptote? How did I know it was at 1?
Constant over 0.
Because if I plug in 1, it's 6 over 0. That's one way. Another way, does he factor? Nope. He's not a whole. I set the denominator equal to 0. Yep. He's not continuous. Wait a minute. Hold on. Pause. The one place that could trip you up is, wait a minute, is the 1 included on what they're looking at? Oh, yeah. All right. MBT does not apply. I'm done. Yep. MBT fails. We'll make it easier. Actually, I should say MBT doesn't fail. This fails MBT. There we go. That sounds better.
Just saying.
For MBT. All right. Go on to B. Determine if the NBT applies. If so, find the value of C guaranteed by the theorem. If not specifically state why it does not apply. continuous, yes or no?
Mm-hmm.
Wait, hold on. How many of you guys are done with B? You should all be done.
I'm done with one, for A.
Number 1, is it continuous?
Yeah.
If you don't like how he looks, you can rewrite him. What is he? Cube root of...
Cube root squared.
Do cube roots have any problems?
No.
No.
problem.
And it's positive anyway, but cube roots don't have any problems. So therefore, is he continuous?
Yeah.
Yes. Number 2, is he differentiable?
Yeah.
What's his derivative?
2/3 x to the negative 1/3.
Apologize, he's a G. Equals 2/3.
2/3 x to the negative 1/3.
Of course he's differentiable. Nope. My guys who said he's differentiable, what did you not consider? The domain of the derivative, right?
No way.
The domain of the derivative. Hold on. Whenever you have a negative exponent, my ones who are falling asleep.
It
Whenever
should
you
go
have a
down.
negative exponent, what's going on?
2/.
Ruh-roh. Where's the derivative undefined? Which is an actual point in the original, but it doesn't let us pass the differentiable condition. He's going to be undefined at... Hold on. Make sure. Look at the interval. Is that your same parser? Look at the interval. Is it a problem? Yep. So therefore, he fails MVT. So can I make any conclusion by MVT? No. Can I make any conclusion by MVT? No. It's like Mr. Shank's test about reading at the end, right? Hold on, pause. We have a fun one coming. You guys ready?
Yes. Where did that go?
Anybody have good vocabulary? Want to read what's next?
Not good.
See if I can pronounce all the words right this time.
Next.
The calculus cops have set up their elaborate speed trap on a busy stretch of road. A suspected pumpkin farmer who uses the road daily to haul his pumpkins to market is suspected of chronic speeding well beyond the posted limit of 55 miles per hour. The calculus cops aim to finally ticket this unlawful transporter of seasonal gourds. The calculus cops set up 5 miles apart from each other, each parked furtively behind a piece of scenery. Calculus cop A spots the farmer with his jalopy. I was getting there. Loaded down with would-be jack-o'-lanterns. As the farmer passes Cop A, he is clocked at a paltry 50 miles per hour. Cop A could have sworn the farmer waves at him as he drives by. Cop A immediately radios calculus Cop B 5 miles down the road, whereby Cop A starts his timer. 4 minutes later, on the dot, Cop B clocks the farmer cruising by at only 55 miles per hour. He clearly sees the farmer wave at him with a giant grin that would make a jack-o'-lantern jealous. After a quick calculation on his field-issued TI 88.5 calculator, he pulls out with his lights on to issue a speeding ticket to the ornery pumpkin farmer. For what speed can calculus Cop B ticket the farmer?
56.
Would this ticket hold up in court of law? Why or why not? We are not talking about the court of law first. We're talking about what speed could he ticket the ornery pumpkin farmer with.
You can ticket him at 56.
You can do a bit higher than that.
But he can ticket him at any one of those speeds.
Good,
Over
man.
60.
Logically.
Huh?
It's over 60, isn't it?
No, it's...
Over 60? Like, is he going over 60 at some point?
We had to
Yes.
pass 56.
We can go higher than that, though.
Why?
I don't know. Give me a reason why.
Oh, because. No.
You got there too soon.
Question. Is this a Rolle's theorem or a mean value theorem? If it has to be one of them.
I'm going to roll. I like roll.
Would it be Rolle's? Does he pass the exact same position twice?
No.
No.
So
I mean, he had to pass...
He's not going at the exact same speed. Which that would have to do with something totally different. Actually, he's not passing the exact same position, my bad. Speed is going to be a derivative, right? Rate of instantaneous rate. They're trying to clock him at his highest instantaneous rate. Or at least at the highest they can possibly prove. What do we know, guys?
We know.
Question, if we just look at the 50, the rate at A and the rate at B, the rate at the beginning, the rate at end, can we clock them at all? No. We can say he's sped up 5 miles per hour, whoop-de-doo, but I'm not looking at the rates. I'm not looking at the slopes. What am I looking at? The time and
that's 5 miles.
the distance. How How did you find rates a long time ago?
We,
Change in
it's dirt,
rate equals dirt.
dirt.
Distance equals rate times time, or rate equals change in
Yeah, time.
distance. It's okay, it's been a while. Change in distance over change in time. Question, kiddos, what can I plug in? To find his average rate. What's his average rate over that time period? 5 miles, that's his displacement, right? His change in position. And 4 minutes. Oh, well, 5/4, what does that have to do with anything? Come on, my chemistry people, what are we gonna do?
Build bridges.
Build bridges, dimensional analysis, what do I do? I have minutes, and I have, I need to make them equivalent, right? So I need,
61.
woo-hoo-hoo, what was his average speed?
79.
Well, that's all well and good, and any rational person should probably say, I think he's going over the speed limit. However, what could they technically prove mathematically with mean value theorem?
Speeding.
You can prove 75. Can you prove necessarily higher?
No.
No. Would it make sense that he probably went higher? Probably. But all I can prove is they're going to ticket him at, because the speed of his, what are we calling, D? D prime of t has to equal 75 miles per hour according to MVT at least some, I can't even write, t equals c. Within, we'll just stop. Within the beginning and end of the scenario, I didn't really label with et cetera, et cetera, et cetera. And would this hold up? Well, it sure should, because what proves it? MVT.
One more.
Make sense? Huh?
Slick.
If only cops these days knew calculus, we would all get ticketed. All right, here we go.
Wow.
Just kidding, they probably do.
You still get told.
Go.
They just
Multiple choice. Multiple choice till the end. Let's finish this up. Come on, guys. As much practice as possible in the next 7 minutes. Huh.
Calculus costs like the best as a biotic grammar.
They have to work in pairs too. They sometimes do, but not very often.
Pairs.
really covers much ground.
But you would be a whole lot more scared of them. Or you should be.
That's like when cops drive on the freeway. I'm so
That's a little bit too zoomed out, huh?
no. I slow down.
I slow down, especially going into Simi Valley. Those ones are speed.
Oh,
Yeah,
they're crazy. You go 1 mile an hour.
Not by experience. I have no idea.
The
Just
windy
heard stories.
roads would get you.
What?
The windy road, when you have to go into Cedar Valley.
Like you're just coming down the hill, like you're just sailing, and
All the
then
bottom.
Sailing, have your flag.
Just stay in the most left lane during traffic.
all right, my distracted ones. Come back to the problems at hand. Does the function
Satisfying.
satisfy the hypothesis of Rolle's theorem? Yes or no?
Yeah.
I don't want to hear yeah.
Yeah.
Is it?
Continuous.
Where does it have to be continuous on?
On the closed interval.
0 to 6.
What's my domain? Come on, it's the square root of pre-calc.
Greater than
I would say
Or equal to square root of 0 is 0, right? No big deal, yeah. So therefore, what's my domain? X needs to be.
Then.
So is it continuous?
Yeah.
Yep.
That's
Differentiable. On. How do I figure that out?
You want to try it?
Well, I'll need to find the derivative anyway, right? If I'm gonna figure out where rolls is true, because the derivative f prime has to equal 0. So, what rule?
That one. Product.
I heard product. That one does not suffice. So then, coming back, give space. Keep falling asleep. Okay, there we go. So then derivative of the first times the second plus derivative of the second. What should go in the parentheses? Did you kill a bunny?
No.
Times u prime. Woo! Bring down the 1/2, make it negative 1/2 times 6 minus x prime. Ooh, that's a negative 1. Now what? Well, all cool kids would get a common denominator eventually, but I guess if you're just looking for differentiability, you're just looking at the domain of the derivative. Question, does the derivative exist everywhere? Nope. Where does it not exist? Right? But wait,
Open.
does it work?
Yeah.
Let me show you why. Guys, what if that was A, that was B? Did we already see this yesterday?
No.
And if I'm looking between A to B, f of A equals f of B, oh, we still have to check that one. Okay, hold on. Question, is Rolle's theorem going to apply in between A to B? Yeah. Why? He's continuous everywhere in between. He's differentiable everywhere beyond A and, well, between A and between B. Does it matter there's a sharp point? No. Now, if there's a sharp point somewhere in between, well, all bets are off. However, this sharp point is not going to have an effect on me looking on the inside. Now, careful. Logic, your logic doesn't necessarily always translate to mathematical properties. The definition says open interval. It does not include 6, so therefore I am good. Differentiable, check. F of B equals F of A. Is that true? Plug in 6. Ooh, that's a 0. Plug in 0. Oh, that's a 0. Okay, yep, those are equal. Now what?
Now we find.
Let's come back to our derivative. And let's say I really want to set him equal to 0, but he's kind of messy right now, so why not get a common denominator? That'd be a great idea. So I would get 2 times square root would be a single, all over 2 square root of 6 minus x, and then he has a negative x out here. That would be 12 minus 3x all over 2 square root of 6 minus x. I'm just setting him equal to 0, so I'm only looking at the top. Good, the bottom is D and E, right?
Right.
So it's going to occur at
4.
questions.
Answers.
How about this one? He's not as much fun.
Thank you.
That's your question, guys. Are we proving whether or not these fit these conditions, or just whether or not these properties that could be true of this function help us figure out where the derivative equals 0?
Second.
Now, if you're looking at this, you might say, uh-oh, I have to start testing, read the whole problem and say, okay, I can just take this for granted that these do or are possible candidates for what f is or how f behaves. I need to figure out which properties ensure that there exists a c in -1 to 1 at which f prime of c equals 0. Question, they're actually just asking which of these fit. Does that make sense? But if I didn't know roles, I wouldn't know what they were asking. We have to get to the point where we see, uh-oh, must there exist f prime equals 0, Rolle's theorem. Wait, what were the conditions for that again?
Must be continuous.
Must be continuous, must be differentiable, and f of A must equal f of B. Okay, that one's easy. What do I do with the other two? Check to see if they're continuous and differentiable. So, cosine cube. Can I plug in anything to cosine and cube them and he's still equal to something?
Yes.
Okay, continuous check. That was a really weird way of saying it. I apologize. Question, what's his derivative going to be?
3 cosine squared.
Is that gonna exist everywhere? Sine's good, cosine's good, sure. Differentiable, check. So question, how about 2? That's a yes, right? And it says it meets this condition, so it still has f of a equals f of b. How about the third one? Continuous?
Yeah.
Differentiable.
Sorry.
One way to think about it is you could think about sine himself and say, wait, if he has an absolute value, what's going to happen? Another way of thinking about it is, how do I take the derivative of an absolute value? Well, here's one way. You could say absolute value only bothers me when I'm not dealing with
On what? Finish it.
If I have an ln of absolute value of u is the exact same thing as ln of regular. So then my life gets a little bit more interesting as I go. Anyway, we'll pick up with this one tomorrow, guys. AP multiple choice tomorrow. Work on homework tonight. You have an AP packet in the works and a practice test coming.
You still going to too?
I don't know. I read my essay yesterday. You haven't had Robert?
Huh?
Robert?
Robert's cool.
Cool.
He's a dis-
He plays bass. I thought he's a bass player.
Did you see his tattoo?
Yeah. He's from Brooklyn. I love that guy.
스트레스 받으니까 과자 사 먹어야지. 맛있게 먹어.
Bye, Miss Day. Thank you.
Extreme value as long as the function is continuous, so I can I don't have to pick up my pencil or draw it, that's the key, as long as it's continuous. If I cut it on A and on B, so if I cut if I cut from the beginning to end, I cut the function, whatever it looks like, extreme, or just cut it, you know how the function can go on forever? If I just cut it at A and cut it at B, aka closed interval,
Right.
including the endpoints. Extreme value theorem just says there is an absolute max and an absolute min, highest and lowest
This
in
one is.
that portion.
This really. Okay. And then what about rules?
Rolle's theorem says, as long as I don't have to pick up my pencil and draw, and there aren't any sharp points for vertical tangent lines. If I cut a function, once again on A to B, including A, including B, then if the heights, because A is an x and B is an x, right? If I go up to a curve and go up to a curve, if the heights are equal, they're the same thing, then no matter how I connect those y's, whether I connect it with a straight line or with a curve or with an undercurve, no matter how I connect it, there's going to be at least one place where the derivative is zero.
Oh, okay.
At least one place where f prime of x equals 0. Does that make sense, kind of?
Where's Kenny? Does he stay here every day?
He does when I stay in here.
Oh.
So frequently, because of football and baseball.
Oh, okay.